So sometimes order of operations is called PEMDAS, which I don't really use that very often. It's especially hard for people who English is not their first language. But P stands for parentheses. And not only is it this symbol, but it can be this symbol. It can be squiggly, and I didn't do very well with that, and even absolute value bars fall in that parentheses category. We follow this order so that everybody does it the same way. So our next value there is the exponents. That's what E stands for. M is multiplication. D is division. The thing about this is that we go left to right when we're working with those. And sorry, missed it. Here it goes right there. Multiplication and division. And finally, addition and subtraction, same idea. We go left to right. Most of you are pretty familiar with that concept. It's something that we learned early on in our educational career back in elementary school. Let's look at an example. It doesn't necessarily have to use everything from the order of operations. But where we're going to start, we're going to start here at the 5 plus 4. So it's 3 plus 6, and 5 plus 4 is 9. That's our first step in the order of operations. Now some of you are going to combine steps, so I'm going to not combine steps here. I'm trying my best at least. So the next part here is that we don't have any exponents, but we do have multiplication and division. And once again, when we're dealing with multiplication and division, we work from left to right. So the next part here is going to be 3. 6 times 9 is 54. And I don't know why I switched colors there. Divide by 3. Let's go back to blue. And then we still have the minus 7. Well, we need to do the division now, because we worked from left, and now we've got 54 divided by 3, so this is 3 plus, and if you need to, you type it into decimals, you type it into a calculator. 54 divided by 3 is 18, minus 7. And then, finally, we really can finish at this point. 3 plus 18 is 21, minus 7. Notice that I did work from left to right. And then 21 minus 7 equals 14. Now, if this problem were on the state test in April, I would simply type it into decimals. But it's not going to be on there. Another problem here. And this one does have exponents in it. It has parentheses in it as well. So we're going to look at the 289, which we don't do anything with yet. We need to start with the parentheses. And our parentheses says 3 times 5. This time, we do have a squared. We do have an exponent. To the second power means squared. So with that exponent here, 15 squared is 225. Again, that's something that you would use Desmos for. And then when we subtract, 9 minus 5 is 4, and 28 minus 22 is 6. Sometimes people don't like these kinds of problems because they have fractions in them. Again, worst comes to worst, you've got Desmos to help you. The idea today is to really do more of it with the process rather than typing everything into the calculator. But what's going to happen, because there's a fraction in here, and it's within the parentheses, which is where we start with the order of operations, is we're going to start and we're going to simplify the top. 36 minus 6 is 30. And we're going to simplify the bottom. 12 plus 3 is 15. Still within the parentheses. And 30 divided by 15. So we're still simplifying parentheses. Where we started with the order of operations, 30 divided by 15 is 2 squared minus 4. Again, 2 to the second power means squared. And then 2 squared. That means 2 times 2. In case you don't know. And 2 times 2 is 4. Minus 4. Which equals 0. Combining like terms. Just a reminder here. When we combine like terms have to be the same variable in the same format. So when we look at this problem here, and we start, I'm going to change up some colors here. If I start with 3x, I'm looking for only terms that have x's in them. Well, that one is a like term. And I'm going to show more steps than I usually do on these problems, just to show my work here. So we're going to put 3x minus 5x together. Next term in the problem is 5x squared. So as we look through this problem, do we have any more x squared problems or pieces? And we've got an x squared here. So this is going to be the minus. Take the sign in front of it. Minus 5x squared plus 8x squared. And then as we take a closer look here, we have a 4. But the only other term that's not underlined is x cubed. And 4 is different from x cubed. So now I have it color-coded so that they're all in that format here. And when we combine like terms, we add the coefficients, or we subtract the coefficients. So 3x minus 5x, 3 minus 5 is negative 2. When we look at the next set of like terms, negative 5x squared plus 8x squared, negative 5 plus 8 is 3. Notice how the x squared remained the same. And then when we finish, the plus 4 and the minus x cubed. So the combining like terms just is a reminder as we go into our remaining problems here, which are going to be the solving equations. So when we're solving equations, remember, whatever operation we do to one side of the equation, we do to the other side of the equation. You want to keep the equations in balance. So the first one, 7v minus 17 is 60. So what we want to do is we want to undo this minus 17. So we'll start by adding 17 to both sides. When we do, we get 7v equals 77. Minus 17 and plus 17 cancels out. And then to finish, 7 times v. To undo the multiplication, we're going to divide. So we're going to divide by 7 here. We're going to divide by 7 here. And v equals 11. Letter B. Again, sometimes students have a little moment of pause because there's a fraction in the problem, but the process is still the same. We want to undo. So over here to the left of the equals, we have plus 5. We're going to try to get the variable by itself, so we're going to move that 5 by undoing plus 5 by subtracting 5 from both sides. And when we do, we get z divided by 6 equals 5. By the way, if you don't like z, use x. You're going to see, at least on one of the practice problems, I used x instead of whatever variable it was. Now, it's z divided by 6. The opposite operation is going to be to multiply by 6. And when we multiply both sides by 6, the 6's cancel out. 6 divided by 6 is 1. 1z. And then 5 times 6 is 30. So as we finish, and parentheses in this problem, we need to deal with that first, just like in the order of operations. So let's distribute. 12 times t plus 12 times 2. Over here on the other side, it's 4, but we can distribute. Be very, very careful. We're distributing the negative. Negative times 3. Negative times positive is negative t. Notice how the negative, it also means the opposite. So what happens is that positive 3 became negative 3. Positive t became negative t. And now that we've done that, what we're going to do is we're going to combine like terms over here on the right side of the equation. So our like terms here are this 4 minus 3. So we still have 12t plus 24. And over here, 4 minus 3 is 1 minus t. Personally, I like to move my letter to the left. I frequently say that. Solve it the way your Algebra 1 teacher taught you, which is most likely that you move the smaller variable to where the bigger variable is. But I tend to like alliteration, and it's not going to make a difference here, because that's the way your Algebra 1 teacher probably taught you. We're moving this t over to the other side. We're undoing, so it was minus, so we're going to add. And if you need a reminder here, this is 1t. So what we end up with then is we end up with 13t plus 24 equals 1. Again, we're trying to figure out what does t equal, so we're going to subtract 24 from both sides. We get 13t equals negative 23. 1 minus 24. And finally, we want to figure out what t equals, so we're going to divide both sides by 13. And we end up with t equals negative 23 over 13. I don't need a decimal. And there we've solved our equations.